So this video covers the organizer that is on page 417. Obviously, the title is Activity Series. We are focusing on metal reactions or metal properties, and the one reaction that we were going to take a look at is redox reactions. Well, you can use chemical reactions, use redox reactions to rank how likely a metal is to undergo oxidation. And so what you are seeing here is exactly that. We've made up some fake metals that you can see in the video. We have M, L, Q, X, Y, and Z. And so they are ranked in what we are calling an oxidation activity series. So what that means is the elements at the top of the series are the ones most likely to undergo oxidation. The elements at the bottom of the series are less likely to undergo oxidation. So what does that mean? That means metal M really wants to lose electrons to become M2+. And that means metal Z doesn't really want to lose electrons to become Z2+. It would rather stay Z. So in an activity series, what you're really doing is you're comparing where two substances are located. When they undergo a redox reaction, something needs to gain, something needs to lose. Well, if the something losing electrons is the one who really wants to lose electrons, then the reaction will happen. But if the substance trying to lose electrons doesn't want to lose them, the reaction may not happen. So this activity series lets you predict that. The one at the top is the one that wants to lose electrons. The one at the bottom is the one that wants to stay neutral. So it doesn't matter where in the list the two substances are. All you have to do is compare where they're located. You don't have to have one from the top and one from the bottom. I could compare M and L right next to each other. M is above L, so M is the one that really wants to lose electrons more than L does. So I've got some examples here to take a look at. So the first example is taking a look at the reaction between Z, should be Z plus and L neutral. There shouldn't be a plus there. Z2 plus and L. Okay, so one of them is an ion, one of them is a metal. What's going to happen? They're going to switch places, right? So Z2 plus is going to gain electrons to become Z. L is going to lose electrons to become L plus. And how do I know what the charges are? Well, I just looked up here in the activity series. Z goes to Z2 plus, L goes to L plus. So now, will this reaction take place? That's the question. What you want to do is you want to go back to the series and look and see where they are. So L is above Z. L wants to be the ion. Z, being at the bottom, wants to stay the element. What do we have? We have the opposite situation. Z2 plus is not the preferred state of Z. Remember, Z would rather be the element. It's at the bottom. It's below L. L is above Z, and so L wants to be the ion, and it's not. So will a reaction take place? Yes, it will. What's going to happen? You're going to have the two elements trade electrons, so to speak. Now, in order to get that to happen, remember that we need to take the half reaction of L and multiply it by 2 because we have to account for both 2 electrons being lost and 2 electrons being gained. But because of where they're located on the periodic table, L is the element that wants to become the ion. Z is the element that wants to stay neutral, atom. So we will get a reaction. So then that would be our redox reaction that we would write. Okay, here's the other example on this organizer. Q2 plus and Y. So if the reactions are going to happen, what will happen? Q2 plus will become Q. Y will become Y plus. And again, how do I know it's just plus 1? Because up in the activity series, that's all you see. So will this reaction happen? Q2 plus and Y. Q is above Y. Q is the one that wants to be the ion more than Y does. Well, if we look, Q is already the ion. So this reaction is not going to take place because they are already in their preferred state. Q2 plus would rather be an ion more than Y would. So we will get no reaction. So at the bottom of your organizer, there are 4 combinations. Pause the video, take a moment or a few moments, and try and predict whether or not a reaction will happen. And if it will, write down what the reaction will be. So pause right now. Okay, so I'm assuming that you paused the video and gave everything a shot, so let's take a look. M2 plus and Z. If I go up here, M is at the very top. M is the most likely element to be +2. It wants to be +2 the most. It's already +2. Doesn't matter where Z is, M's at the top, so we're not going to get any reaction there. Now I've got X 3 plus and L. L is above X. L is the one that wants to be the ion, and it's not. So we are going to have a reaction. So X 3 plus is going to react with 3 L's, because remember we have to have the electrons balance out. So I'm going to get X, and I'm going to get 3L plus 1s to make sure that I have the right number of electrons moving. Okay, if we go up, next one, M2 plus and Y. Again, M2 plus, M is all the way at the top. M's already an ion, so we're not going to get a reaction there either. So no reaction here. And then finally, the last one is Q and Z2 plus. So where are they in our activity series? Q is above Z. Q wants to be the ion. It is not the ion, so we will get a reaction. So Q is going to react with Z2 plus to create Q2 plus. I don't have to worry about electrons because they're both +2s, plus Z. So these, the second and the fourth reaction will take place, the first and the third will not. So you've got a couple of problem sets to do to practice that.